Hello everyone. So today we'll study about chapter 3 and this chapter is about the vectors. So we'll study about the vector quantities and their properties in this chapter. So before vectors, let's study about firstly the scalars. So scalar is any quantity in physics which has magnitude but no direction associated with it. So, and what we mean by magnitude, that just a numerical value with some units. So for example, speed is 20 meter per second, distance 10 meters, age 15 years, heat 1000 calories, like this. So when we are saying that speed is 20 meters per second, we are not mentioning any direction with this. So that means this is a scalar quantity. Distance just 10 meters. You don't know whether this is towards north direction, east direction, south direction, or any specific direction. So such quantities which just has magnitude with some unit, they are known as scalar quantities. Then we have vector quantities, and vector is any quantity in physics that has both the magnitude and as well as direction. So when we say velocity, and velocity is a vector quantity, velocity is 20 meter per second with north. So here you have magnitude with the units, which is 20, and you also have a direction towards north. So velocity 20 meter per second towards north, acceleration 10 meter per second square towards east, then you have force 5 newtons towards west. So all these, they are example of vector quantities which has magnitude and as well as direction associated with them. And this is how we represent a vector quantity. So you just write down variable and then you take an arrow over that. So that is a vector quantity. So this symbol represents a vector quantity. So vectors are typically illustrated by drawing an arrow above the symbol, and the arrow is used to convey the direction and magnitude basically. Properties of vectors. Number one, equality of two vectors. So when we can say that the two vectors are equal, if they have same magnitude and they also have same direction with them. So for example, if you check these two vectors, you have AB vector and you have CD vector. So if you check, they both have equal magnitude. This is the magnitude and they both are pointing in the same direction. So that is why they both are equal. So your AB vector is equals to CD vector in this case. Next is the zero vector. Zero vector is denoted by bold 0 and which has length 0 and there is no specific direction with this. So it's just a zero vector when there is no magnitude and no direction. Next is negative vectors. So two vectors are said to be negative if they have same magnitude but they are 180-degree apart, means they are just opposite in direction. So for example, if you check this vector A and vector B, right now if you see they both have equal magnitude and they both are pointing in the same direction. So in this picture, your vector A is equals to vector B. But if I just reverse the direction of this B vector by 180-degree. So initially this was the direction. What we did, we just reversed the direction by 180-degree and now this is the direction. So A vector will be equals to negative of B vector. So now these two vectors, they are negative vectors and negative vectors are which have same magnitude and just the opposite direction. Next is scalar multiplication of vectors. So scalar multiplication of vector, for example, if you have this A vector given to you and this A is 12 in magnitude and the angle is 105. So that means this angle with the x-axis is 105, and the magnitude of this A, this magnitude is your 12. So suppose if the question is find the vector 2 times of A. So you have the magnitude for A, and if you want to find 2 times of A, then that will be your 24 in magnitude with the same direction, that is your 105. So this will just double the magnitude, and you will have this 12, so this total magnitude will be 24, and this angle will be again the same, your 105. If your question is to find negative of A, negative of A, so negative of A will be this. So means negative of A, just the same magnitude, again the same magnitude as it was here for the A, but just reverse the direction. So if your angle is 105, now the angle is 285. So how you're gonna get that angle? So your 105 plus 180 will give you the angle for this negative A, that is your 5 and 8 and 2. So 285 will be the angle for this negative A in this picture. And similarly, if you want to find the negative of half of A, that means the half magnitude of this 12 A vector, and then negative means again the angle will be this 285. So this 285 and this 285 for these both. So this is how we just do the scalar multiplication for the vector. And now resultant of two vectors. So resultant is the sum of the combined effect of two vector quantities. So now it depends that how the vectors are given to us. If you have vectors in the same direction, for example, if you have these two forces 6 Newton and 4 Newton, and they both are in the same direction, you can simply add them and you will get 10 Newton resultant, and that will also act in the same direction. But so this can be the case and this can be the case for the same direction vectors. So if you have two displacements, so if you have two displacements 6 meter and 4 meter, and they are also in the same direction, you will get the resultant 10 meter in the same direction like this. But if you have vectors in the opposite direction, so for example, if you have two velocities 6 meter per second in this direction and the 10 meter per second in this direction, then your resultant will be the subtraction of these two vectors, and the resultant will have direction of the greater magnitude. So whatever is the direction for this 10 meter per second, that will be the direction for this resultant. And suppose these two forces 6 Newton and 10 Newton, they are also acting in the opposite direction like this. So again you will get the resultant 4 Newton, and it will be in the direction of 10 Newton force, which is the higher magnitude of these two forces. Next we have parallelogram law. So in the last slide we did that we can have vectors either in the same direction or we can have vectors in the opposite direction. But all these vectors, they were along the same axis. So now in this, suppose if these vectors, they are not on the same axis but they are at some angle with each other. So now you have these two vectors, A vector and B vector, and they both are at some angle with each other. So then how we are going to find the resultant for these two vectors? So first is the parallelogram law. So when two vectors, they are joined tail to tail, So for a vector, this point is known as tail of the vector, and this point is known as head of the vector. So if two vectors are there joined tail to tail, then just complete the parallelogram, and then resultant is found by drawing the diagonal of this parallelogram. So this line will give you resultant of these two vectors A and B vector. So we did the parallelogram law, and next is triangle law. So when we apply the triangle law, if two vectors they are joined head to tail to each other. Now see, the difference between these two laws is, in this case, the vectors they are joined head to tail. So head of one and then tail of the second one. So this is how they are joined to each other. So if this is the case, then how we'll find the resultant? Then draw the resultant vector by completing the triangle. So this side, the third side of the triangle, which is the closing side of this triangle, this gives us resultant of these two vectors A and B. So this is how you find the triangle, the resultant from using the triangle law, and resultant by using the parallelogram law. So just make sure whenever you are doing the triangle law, you have two vectors head to tail to each other, and the third closing side. What we mean by closing side? This side is closing the triangle and taken in the opposite order. So this was the order of the vectors, this side in the triangle, but this vector is in the opposite direction. You're not getting direction in this for resultant. You have direction this one for the resultant. So this is how we get resultant by using the triangle law and parallelogram law. Now, adding the vectors graphically by using the polygon law. So polygon law we use when we have more than two number of vectors. So when you have many vectors, just keep repeating the process until all are included. And the resultant is still drawn from the origin of the first vector to the end of the last vector. So now suppose you have these four vectors, A vector, B vector, C vector, and D vector, and you need to find the resultant for these four vectors. So what you are going to do, you will connect all these four vectors head to tail, head to tail, head to tail, like this. So once you will attach all these vectors like this, so you can apply your triangles laws. So this line will give you resultant for A and B. You will further do the same thing, and now for this triangle you will get this resultant, and this resultant will be the summation of this line with this line. So you will get A plus B plus C. Now again you are going to repeat this. So you will have this triangle, this triangle, this triangle, and the closing side will give you, this is the closing side of the triangle. This will give you the total resultant, and that will be your A plus B plus C plus of this D. So that is the total resultant of your all the four vectors A, B, C, and D, and that is the closing side of this polygon taken in opposite order. So all the vectors A, B, C, this was the direction for all the vectors in this direction, but the resultant is now coming in this opposite order in the polygon. So vector subtraction. Vector subtraction is a special case of basically vector addition. Whenever we add the negative of a subtracted vector, for example, this A plus negative of B is addition of a negative vector to a vector. So continue with the standard vector addition procedure. So suppose this is your A vector, here is your A vector, and then here you have the B vector. So now if this is the B vector, your negative of B vector will be this, right? So negative B means with the same magnitude but just in the opposite direction by 180 degree. So when you have this triangle, so this is the triangle now, this side, this side. So now your closing side is this of this triangle and your vectors were A and negative of B. So you are just adding this basically. So your A vector plus negative of B vector, and that is basically the same, your A vector minus of B vector. So that is the subtraction of vectors. So if two vectors are going in opposite direction, you subtract them. So for example, let's check this example. A man walks 54.5 meters east and then he goes 30 meters west. Calculate the displacement relative to where he started. So suppose this is your 54.5 meters towards the east, then 30 meters is just opposite 30 meters towards the west. So if you want to find the displacement, what was the displacement? Displacement delta x, it was your final position minus the initial position. So now your displacement will be just this. So you will have 24.5 meter. That will be the answer. Now, next is components of a vector. So now this is really important for the vectors. So when we are saying vector, vector means any quantity which has magnitude as well as direction. So a component is a part of a vector. A component is a part of a vector, and it is useful to use rectangular components, and these are the projections of the vector along the x and y axis. So this is your xy coordinate and your vector is this A vector. Now this A vector, this will be having some points here. So these points are for example A of x and A of y. What is the meaning of this thing? That means these coordinates gives you projection of this vector on x-axis and on y-axis. So on the part of this A vector, on x-axis you have A of x and on y-axis you have A of y. The components are the legs of the right angle whose hypothesis is this A. So this was the case in the previous slide. Here you were having A of y, here you are having A of x. So this whole thing A of y is basically equals to this. So you can take a triangle like this also. So this is your A of y, this is your A of x, and this is your total A vector, and this is your A vector. So if you check the right angle triangle, then your A of x, the base from this right angle, is A times cosine of theta, AY is A sine of theta. So now if you will square and add these two equations, for example equation 1 and equation 2, what you are going to do, just square and add both the equation. So your A of x square plus A of y square, what you will get, this will be equals to A square cos square theta plus A square sin square theta. So how you can write it? A square is outside, just inside you can take cos square theta and plus sin square theta, and from your trigonometry this whole thing cos square theta and sin square theta, this is equals to 1. So if this is equals to 1, so you can say that this a is equals to under root of, or a square is equals to ax square plus a of y square. So from this you are getting this relation that a is equals to magnitude of ax square plus of ay square. So this is how you're going to get magnitude for any vector. And you can also get the direction. Direction is basically this theta, the projection of this vector a. So to get the direction for this vector, you're going to apply this relation. So if you will divide here this equation number 2 by equation number 1, you're going to get tangent of theta and ay over a of x. Ay over a of x. So this is giving you the projection, the direction of the vector. Now, the terminal points A has the coordinates of in the form this A of 1 and A of 2. So if you have just a vector in 2 dimension in any plane, xy plane, then you're just going to have 2 coordinates. But if you have a vector in space or in 3 dimensions, so this is the case of 3 dimensions and this is the case of vector in 2 dimensions. So in 3 dimension you have coordinates a1, a2, a3. So that means a1 is the projection on x-axis, a2 is on y, and a3 is on z-axis. Now the very important thing in vectors is about the unit vectors. So we saw already that we have the projection of vector a, ax on x-axis and ay on y-axis. Now you can write down a vector by using these unit vectors and these projections. So this is how we are going to write the vector a is equals to ax I cap plus ay j cap. Now what is the meaning of this thing? So this I vector I cap is basically giving us the direction along the x-axis. So any direction on x-axis is I cap. Any direction on y-axis is given by j cap. Any direction along z-axis is given by k cap. So now since you have this 2-dimension projection here for the vector, and so how you're going to write the vector? Ax is the magnitude on x-axis, I cap is giving you the direction along x, ay is the magnitude along y, and j cap is giving you the direction along y. So the unit vector notation, how we generally write the vector. So for example, if you see, if you have this vector A, it has projection 4 on x-axis. So 1, 2, your 3, and here you have 4. And on y-axis, it has 1, 2, and 3. So how we are gonna write this vector? So it has 4 magnitude in x direction and 3 in y direction. So that means 4 I cap plus 3 j cap. So since this is your vector and it has 4 magnitude on x-axis, it has 3 magnitude on y-axis. Now since 4 is along x-axis, so we always attach I for the x and we attach j for the y. So this is going to be your vector A, 4 I cap plus 3 j cap. So the hypotenuse in physics is called the resultant or the vector sum. This is the resultant or the total vector, and the legs of the triangle are the components. So these are the components of the triangle and this is the total resultant for these two vectors. And this is known as the horizontal component and this is known as the vertical component. So for this example, vector A is described algebraically as minus 3, 5, and while the vector B is 4, negative 2. So find the value of magnitude and direction of the sum of the vectors A and B. So if you have given these vector notation in this form, negative 3 and 5, what that means that a vector is equals to negative 3 on the I cap and 5 with the j cap, and b vector is 4 I cap negative 2 j cap. So the addition of these two vectors will give us another vector c, which will be a vector plus b vector. And the important part is now how you're going to add these two vectors. So you will add the I components together and the j components together. So here with I you have negative 3. Here with I you have 4. So negative 3 plus 4 is with the I cap, and then 5 with negative 2. So you have 5 negative 2, this will be with the j cap. So your resultant is 1 I cap plus 3 j cap. So from this you are getting this resultant of these two vectors, that means that is giving you 1 I cap plus 3 j cap. So if you check this, C vector is, again you can write Cx I cap plus Cy of the j cap. So that means your Cx is 1 and your Cy is 3 for this resultant vector. Now you got this vector as the resultant, that C vector is equals to 1 I cap plus 3 j cap. But in the question, if they ask you to find the magnitude of the vector, so this is to find magnitude of the vector. So your resultant vector is this 1 I cap plus 3 j cap. This is to find magnitude. So magnitude, how you're going to find? The under root of 1 square plus 3 square, and that will give you 3.16. So magnitude, as we have seen, magnitude is just a number. So this is how you are getting just a number, the magnitude of this vector C vector. And how you're gonna get the direction of the vector. So direction is this: theta equals to tangent inverse Cy over Cx. So here tangent inverse Cy is your 3 divided by 1, and you will get this direction 71.56 degree. So that is the magnitude. So here you have this as the magnitude of the vector C, and this is the direction of the vector C. So these are two basically your like the answers of this whole example. So you need to find for this firstly the vector in terms of this unit vectors. Once you have this, you can find the magnitude, and then you can find the direction for the vector. Now non-collinear vectors. So when two vectors they are perpendicular, you must use the Pythagoras theorem. So we can also find the resultant by using this. Suppose a man walks 95 km east, then 55 km north. Calculate his displacement. So suppose 95 km east is this, then you have 55 km north, then this will be the resultant, right? So you can also find this resultant just by using your Pythagoras theorem, and that is C equals to under root of this a square plus b square. So your C, the resultant of these two vectors, you're gonna get this is the magnitude of the resultant displacement of these two vectors. So once you have the magnitude of the resultant, you can also find this direction for these two vectors, the resultant of vector. So that will be tangent of y component divided by the x component. So your tangent theta y component to the x component, this is this. So tangent inverse of this number will give you 30 degree. So the direction of this is your 30 degree, and you already calculated the magnitude, that was your 109.8 kilometer. Let's try this example. It's saying A bear searching for food wanders 35 meters east, then 20 meters north, and then frustrated he wanders about another 12 meters west and 6 meters south. Now calculate the total bear's displacement. So now if you check, you have almost 4 vectors, right? 35 meter east, 20 meter north, 12 meters west, and 6 meters south. So let's draw this diagram. So we have 35 meters east, we have 20 meters south, 6 meters, 12 meters west, and then 6 meters south. So you just have to figure out how you are gonna find your total displacement. So total displacement is basically this thing, right? So let's see how we will find it for this problem. Firstly, let's take 35 meter and 12 meter. So if you will take these two vectors, 12 meter, the 12 meter west and 35 meter east. So the resultant of these two will give you 23 meter east, and the resultant of 20 meter and 6 meter south will give you 14 meter north. So for this one and for this one, you're gonna subtract these two and you will get this resultant 14 meters towards north. Now you have these two vectors. You have 23 meter west and you have 14 meter north. So out of these four, you got two resultants, and then what you can do, so you will, you're this 23 meter east and you 14 meter north. Now you need to find the resultant for these two. So that will be the closing side of the triangle taken in the opposite order. So that's basically the displacement of all those four vectors. And this is, you can find just by using your this theorem, or ax square plus ay square, and that is your, you will get the magnitude 26.93 meter, and direction you can find out tangent theta, the y component over the x component, so that is your 31.3 degree. Now we have multiplication, the vector multiplication. This is generally of two types for the vectors. One is dot product of vectors and one is cross product of vectors. So dot product of vectors, this is also known as scalar dot product. So dot product is, you are multiplying two vectors by this dot, a dot b, and that is equals to ab cosine of phi. So if you have, for example, a vector here with the magnitude a, and the angle of a vector is this theta 1, and then your b vector is this with the magnitude b, it has the angle theta 2. Then the dot product takes the angle between these two vectors, which is phi. So phi is basically this theta 2 minus theta 1. So the dot product of two vectors a dot b is magnitude of a, magnitude of b with cosine of phi. And we can also write down the dot product of these two vectors in the form of components like this. So a dot b is equals to, what you're going to do, you're going to multiply the I components with I, so that is ax bx plus j with j, that is ay by, plus k with k, that will be az and b of c. And why this is so? Because when you do the dot product, I dot I give you 1 and I dot j give you 0. So that's why we are not multiplying this with this and this with this or this or like this. So I dot I is 1, j dot j is 1, k dot k is 1. So this is just the dot product or the scalar product. And if you have the vectors in this form, the magnitude with the angle, magnitude with the angle, then your dot product is just product of the magnitudes, which is your 12 and 5 in this case, and cosine of the 5. Cosine of the 5, as I told you, is the angle theta 2 minus theta 1. So here you have 65, here you have 30. So your 5 will be 65 minus 30, that is your 35. So this is also, you can find the dot product of two vectors. So the scalar dot product again, so if you have these vectors in the terms of 3i cap minus 4j cap minus 5k, 2i plus 7j plus 3k. So your dot product is just multiply I with the I, that is 3 into 2, j with the j, that is minus 4 into 7, and k with the k, that is your negative 5 into 3. So your total answer is negative 37. Now, what is the significance of the dot product? So dot product basically gives us a scalar quantity if you check. So when you are multiplying two vectors, you are not getting a vector. After multiplying these two vectors, you are getting a scalar quantity which just has a magnitude and no direction associated with it. And the next part is the cross product of two vectors. So dot product is a dot b, ab cosine of phi, but the cross product is vector cross product or the vector multiplication. A cross b is a b sine of phi. So you now, instead of cosine, you take sine of this angle. So that is just the cross product for these two vectors. So we can find the vector cross product by using matrix form, but just make sure that whenever you have two vectors and you are doing the cross product, so the third vector give you the direction like this, which you can find by using your right hand thumb rule. So you have this vector along this your palm. Palm is the second vector B, fingers are the first vector your A, and you will get the resultant by your thumb. So in this example, you have 5 magnitude with the angle 30. You have vector B with 12 magnitude with the angle 180. So your cross component, this cross product will be, A cross B will be AB sine of theta. So AB sine of theta will be your 12 into 5 magnitude and sine of 150, because 180 minus 30 is your 150. So your resultant is 30 times k cap. You can find the direction by using this thumb rule. So summary of this chapter is important. The components, how you're going to find the unit vectors for the vector. So and these are the projections: ax, a cos theta, ay is a sin theta. How you will find the magnitude of a vector, how you're going to find the direction of a vector. So if you have different vectors, how you'll find the addition of vector, then multiplication of vector, scalar multiplication, and dot product and vector product. If you have any question, please write down in the discussion thread, guys. Good luck. Thank you.